Hey everyone, in this video we're going to start looking at probability. So before we get too far into it, we're just going to look at question 1 and see what we can figure out. So using the spinner given to the right, answer the following questions. Find the probability of spinning an even number denoted as P of even. So just imagine I was to spin this around once. Just what are the odds that I would end up getting an even number? Well, notice we have 2 and we have 4, so there's 2 potential ways to get an even number, but there's 5 total sections, so it's going to be 2 out of 5 for us in this case. Now, find the probability of not spinning an even number. So that's, in this case, the ones that aren't are the 1, the 3, and the 5. So that's 3 total out of 5 total sectors. Okay. So before we really define probability, let's look at a couple vocab words that we need to kind of know about. So any happenings whose result is uncertain is called an experiment. The possible results of the experiment are outcomes. The set of all outcomes of the experiment is the sample space of the experiment, and any subcollection of a sample space is an event. So you don't really need these words particularly, but we're just using them to understand the bigger picture of probability. Now, when we make a definition here, it's the probability of an event E occurring is given by the ratio of P of E equals N of E over N of S. So probability, that capital P is the probability. Probability is always going to be either in a fraction or a decimal or a percentage because N of E, notice, is the number of outcomes that fall into the event, and the number of S is the outcomes that fall into the sample space. So basically, whatever my sample space is, that's my total. So in the first one we did, that first exercise, my sample space was 5 because there was 5 equal boxes or sections of the circle that I could have spun and landed on. Now we wanted even, so that was the event we wanted. So it was 2 out of 5. When we wanted not even, when that was the event we wanted, it was 3 out of 5. Okay? So what you really should understand here, though, is that anytime we're talking about probability, because it makes this fraction kind of form, it always must fall between 0 and 1. So think about our first example again. We had 2 out of 5 and 3 out of 5. Those fractions fall between 0 and 1. Okay, you can convert them to decimals. They also still fall between 0 and 1. Now, think about it. We don't actually ever have somebody who can get 125%, right? Like sometimes you'll hear someone say, how hard are you going to work? And they're like 110%, but that's because they're trying to show some extra confidence. It's not actually possible to give more than that, right? So this, when it's 1, it's like the same as 100%. We know it's definitely going to happen. So something that could definitely happen, if I went back to that first spinner and I asked you, what's the probability of you getting 1, 2, 3, 4, or 5? It's definitely going to happen. No matter what, if I spin, I'm going to get 1, 2, 3, 4, or 5. So it's definitely going to happen. So it's 100%, right? It's 1. 0 is something that's impossible. If I asked you, what's the possibility from the first question that you would spin a 6? Well, there's no 6 on the spinner, so it's impossible. It can't happen. So it would be 0 out of 5, and it would just simplify to 0. Okay. One other definition I want to talk to you about, though, is complements. So I'm going to go back to this first picture again. A complement is basically the opposite of something. We have complements in this first problem as even and not even. So a complement is when you have one event and then you have that event but not happening. So even and not even are complements of each other. If I said raining and not raining, those are complements of each other. But notice, Raining and sunny, those are not complements of each other because there's still other situations that could happen. Rainy, cloudy, like you just can't assume it. The only way it's a complement if it says the word not. Okay, so with that being said, the other thing you should notice about complements, like so if I have the probability of even plus the probability of not even, it will always equal 1. Because think about it, 2/5 plus 3/5, that's the evens we said was 2. The not evens, there's 3 of them total. So that gets us 5 out of 5 because you're doing one scenario and then the opposite, like the not of that. So that's always going to equal 1. So it's just something you should keep in mind that we will get into a little later. But in question 2 here, consider the spinner shown below that has been divided into 8 equally sized sectors of the circle. And we have, in this experiment, we're going to let A be the event of being an even number. So for us, A in this case is going to be 2, 4, 6, or 8. And event B in this case will be a prime number. So our prime numbers here are 2, 5, 3, and 7. Okay, remember those are numbers that the only things that are factors are itself and the number 1. And so we have that. Now we're going to fill in the diagram with the actual numbers from the spinner. So we have evens and primes. The first thing I want you to notice, though, there is one that overlaps. So there's only one number that's an even and a prime. So that goes in this overlapped section here of both because it satisfies both. Then for the evens, we have the 4, the 6, and the 8 still. So that whole circle, though, is the evens. That's why the 2 is still okay. And then for the primes, we have 5, 3, and 7. And again, that whole circle is making up the primes. But then there's still one number we're missing, right? If I look at all those numbers, I see 1, 2, 3, 4, 5, 6, 7. There was one that was neither. The one that was neither here is 1. So that goes on the outside of the circles, but still inside the box because it's still a part of the total sample space, right? 1 through 8 was our sample space, so it's in the total number there. So we still include it in the picture. Now, a couple more definitions we need here is a set of a collection of things that satisfy a well-defined criteria. So we have a set of numbers, like we had the evens, we had the primes. Those are your sets. When you have 2 or more sets, you can either have the union and the intersection. Now, primarily, we're only going to deal with 2 sets of numbers in Algebra 2. But the union is bringing everything together. So when I talk about the union, I'm looking at everything within both of these circles and the intersection there. So it's like the key word for union is or. So A or B is indicated by this U kind of shape in between for union. And you can either be even or prime. So it's all of those numbers within the circle. Okay. And when I'm looking at that, so for any of those numbers, so if you can be even or prime, we're looking at 2, 3, 4, 5, 6, 7, 8. So, because it's any of the possibilities, this or that. Now, an intersection is a little stricter. So that's when you see the word and it's like an upside down N, or it's like an N, if you will, rather. And that's just the piece of both have to happen. So the intersection is being prime and even. So I have a little bit stricter rules on it here. So the only one that fell in between here was the 2. Now, when I consider the equation N of A or B equals NA plus NB, will this always hold true? So let's see. N of A, so think about A. The number of A we had was 4, right? And the number of B was also 4. So when I count up those numbers, I get 8 total. Okay, so that should match what I had in the union here, but notice it doesn't. I have 1, 2, 3, 4, 5, 6, 7, 8. I only have 7 numbers there. So the reason why is because think about this number 2 here. We counted 2 twice. Because it was an even and it was a prime. So to make sure we do that, the correct modification to this formula is going to be if you do n of A plus n of B, you have to subtract out the intersection of A and B. Okay, and that's just that symbol for and. So you always have to subtract out the intersection so you don't count it more than once. And so let's look at a two-way table now. So a two-way table is the same idea as our Venn diagram, but it just shows up our pieces and overlaps in a different way. So a small high school surveyed 52 of its seniors about their plans after they graduate. They found the following data in the table. So they based it on gender and whether or not they were going to college. So M is equal for male, F is female, C is going to college, and N is not going to college. So in this case, when I'm looking here, the number of males that are going, or the number of males that were totaled, so males here, it's just asking about the males. So that is down that column here, and it's asking for the number for N, so that's 30. Now, for females, we're looking at the total number of females, that's 22. Okay. Number of college, okay, so again, we're going across for the total number is 29 of them. And not going to college, total number is 23. So that's just asking me about the number specifically. Okay, it didn't ask me anything about probability yet. So that N is just the number of people. So the number of males and going to college. So what you can do in a case like this, when we're talking males and college, it's the intersection. So males is going down, going to college is this way, so it overlaps here. That's the number of them doing both. So it was the intersection where those two columns, that column and the row meet. Okay, notice female in college, in this case, that's just the symbol for and again, so we're looking for the intersection. So female, college, that was this one here for 13. Now for female or college, when we're doing that, we're looking at the total amount of females, which was 22, plus the total amount of college, which was 29. But we're talking about the number here, so we have to subtract the intersection of that. Okay, and so we would add that up, and we would get 38. So there's 38 students who are either female or going to college, and we just subtract out the intersection of both of them. Okay, now here's where it changes, because now we're actually doing the probability. What is the probability that a person picked at random would be female who is going to college? So the probability of this, a female who is going to college, right, is in this spot here, but the probability is out of the total amount of people surveyed. So 13 out of 52. What is the probability that a person picked at random would be female or someone going to college? So in this case, again, we're doing probability. We already got our or, so that's going to be the 38 out of 52. Okay, so it's the same as doing 22 over 52 plus 29 over 52. Subtract the 13 over 52. It's not going to be just adding the 2 because the intersection would count twice then. And we said it before, but our probability of A or B is the probability of A plus the probability of B.